Hi, I'm Mojo. I just released my first game on Steam, Droppy Ball, and I also just released it on the Play Store for free. Go check it out. I'm currently working on my next game, Loop Cell. I work on it on stream every weekday. Come hang out while I fumble my way through learning game dev. So the other day on stream, I switched things up a little bit and reacted to a video recommended to me from a chatter. So I thought, why not upload it? Here it is. Yeah, I'm gonna go over it for sure. All right, so let's start here. I've been learning Raymarching on and off for almost a full year now. So I don't know what Raymarching is. I'm gonna assume it's gonna tell me. I'm not gonna look it up. This Raymarched planet shader was a happy accident after many failed attempts, and this devlog covers that full journey. Cool. And then they have a game. Check that out in a sec. We're going in.
What you're seeing on screen is all one single compute shader that took me approximately 100 days to make, and it's part of my goal to make an entire real-time rendered galaxy. But the insane journey to get to this point actually started a full year ago. So, to understand how I got here, let's go back to that point in time. The story actually starts roughly 15 months ago, when I was 5 months into working on my current and first commercial game, Scrapernauts. Scrapernauts has to be its own video, but all you need to know for now is
that was nice. That is some nice animation. I really wait. We're gonna watch that again.
Scrapernauts has to be its own
That is cool.
video. But all you need to know for now is that around the 5-month mark, this was the time I got really interested in shaders, thanks to a YouTuber called Rujik the Comatose. Seeing that their game was made in Game Maker and looked so stunning, it immediately snapped me into the realization that the engine I'm using isn't the problem, I'm the problem. And from there, my hunger for shaders grew.
Do we know what engine they use? I'm just curious. Maybe we'll find out.
Started by making terrible water shaders that looked more like poison swamps. But as time went on, my understanding of shaders grew, and I started to make decent looking shaders.
Yeah, I was noticing the cloud. Yeah, the cloud shader. That's insane. I love that. They'll talk about it. Okay.
An engine effect shader.
Oh, okay. I see.
You should go wishlist Scrapernauts, by the way.
I should go wishlist it. I will in a sec.
There was still one issue. I couldn't satiate all my hunger for shaders in an entirely 2D game. Stuff like raymarching and ray tracing, which I was dying to dip my toes into. And exactly 1 year ago, this is how the story began. So, really quick intro to raymarching for those who don't know what it is.
Hey, it's Godot.
I'm not going to go too deep into it because there's so many great videos that already do that, but hopefully this should give those who don't know what raymarching is enough info to keep up with the video.
Yay!
Raymarching is an alternate form of rendering, primarily used to render volumes such as clouds. And speaking of, the first type of raymarching I'll show you is fixed step raymarching. But in this example, I'll be showing you what it looks like to render a solid circle. Now, this is a side-on view. This is the camera origin. You can think of this like your eye or your player's eye, and it's often referred to as the ray origin. For each pixel on the screen, a ray will be shot out from the ray origin in said direction. Now you'll see why this is.
Yeah, so this is Godot. Now I'm curious. They were showing Ray. Yeah, okay. I was going to say it's probably an asset, right? But yeah, this is probably some sort of
called fixed step
third-party thing, right?
Each ray.
Actually, let's just check real quick. Godot Raymarching.
It takes a fixed step size forward and then it checks for collisions. It repeats this until it hits something. But as you can see, the collision detection isn't accurate to the surface of a circle. This is why fixed step raymarching is often used to render volumes and not solid objects. So here's what that code looks like. So if you follow the Godot advanced post-processing page, we're basically starting from that point. So the collision inaccuracies in fixed step raymarching manifest as banding artifacts. And in
That's
the
cool.
case of volumes, instead of checking for collisions, the ray accumulates density and calculates lighting. Sebastian has an amazing video explaining how this works for those who are interested. For solid objects, there's another type of raymarching much faster, signed distance field raymarching. This type of raymarching uses the signed distance field of an object to make each ray travel the maximum safe distance it can without hitting said object, and it does this every step. As you can see here, it dramatically reduces the amount of steps taken. The caveat is that you must be able to represent the object you're colliding with as a signed distance field. And it's also not as efficient at grazing angles, which you can also see here as the rays closest to the circle take many more steps and sometimes don't even collide. Regardless, I've added a link to the description where you can learn more about signed distance field raymarching with a bunch of great examples.
Whoa.
Anyway, I'll return to the technicalities in a bit. For now, let's get back to my first adventure in raymarching. Now, because I did this in GameMaker, it caused a bit of a headache. This is because GameMaker doesn't actually support SSBOs, 3D textures, or compute shaders. But because of that, I had to figure out how to encode a 3D texture into a 2D texture, and in the process, I ended up learning a lot. So that was my first experience with raymarching, and at the end of the 2 weeks, I'll be honest, I felt a bit underwhelmed, because I couldn't use this in Scrapernauts. So instead of returning to Scrapernauts like a responsible person, I of course started another side project. And of course, I used GameMaker again, because I was the most comfortable with it, but in hindsight, I should have just bit the bullet and switched to Godot. It would have saved me at least 50 hours of trouble, but regardless, I started making a 3D quadri mesh-based planet. The plan was to raymarch the atmosphere.
Okay, so I'm a little confused here. So raymarching, I understand like what it's doing. It basically is able to show volumes from the player's perspective only, right? Like only render what they can see, essentially, right? With rays. But I don't really understand what they are using it for. So like
saved me at least 50
right here, like I guess it's like
was to raymarch the
decreasing. Here, let's go back a little bit. It's like decreasing the quality, like the level of detail as you go back. Is that what's kind of going on? Like I don't know if I completely understand yet what the raymarching is for. Also, like ray tracing is just like it's way harder to render than just a normal camera, right?
3D quadri mesh-based planet. The plan was to raymarch the atmosphere and clouds, but keep the planet mesh-based.
Okay, so the planet is mesh-based. That makes sense. Okay, so it's for the clouds. Got it. Okay, so then the clouds, and what they were saying before was that raymarching is able to like add opacity as it goes through these like translucent volumes. Okay.
But as you can see, I didn't really get the proportions right, and it looks more like a cartoon interpretation of a planet. I also didn't really understand shaders all that intuitively yet, so I ended up separating all my shaders. So it ended up being one pass for the atmosphere, one pass for the clouds, one pass for the planet, which led to a lot of unnecessary reads and writes.
Interesting.
I also got some unplanned experience with DDA raymarching in this project. And that was because I wanted to try and make a voxel spaceship, but it turns out refreshing a 3D model multiple times per second in GameMaker is very slow. Just by switching from a CPU-side mesh reconstruction to a voxel DDA raymarch setup, it allowed for the voxels to be updated thousands of times faster. And of course, this system allowed me to make use of the prior knowledge I gained to write the 3D voxel data to a 2D texture. It still wasn't anything too fancy, no acceleration structures, just a 3D array encoded to a 2D texture. This was still a very important experience though. Also, as you can see in the background, I tried some different planet generation settings and cloud settings to try and make it look a little less cartoon-like. It was a little bit better, but I still wasn't satisfied. So considering that I still wasn't happy with my clouds or planet, and having gotten sick of GameMaker and how slow it felt to get anything 3D done, I decided to switch to Godot. Here I tried an entirely new form of cloud raymarching using a 2D weather texture to extrapolate broader cloud shapes and using smaller 3D textures to adjust the cloud's fine-grained look. I tried this based on a paper I found, and I'll also leave that in the description. It's a great resource for this particular.
All right, I'm definitely realizing I have a lack of knowledge on raymarching. We're gonna learn a little bit more about it real quick, just so that I can kind of understand the video a little bit more. A rendering technique. So it's well suited for rendering procedurally defined scenes and complex shapes that are difficult to model with traditional meshes. Okay. All right. I think that's the one step that I was missing, was like what's it getting me? I guess it's literally for these clouds, right? Like that's the big deal, right? Is that you can fly through the clouds and it'll still render what's in front of you because it's able to do that with rays instead of like in Minecraft when your head goes into a block, you can like see under the entire world kind of thing because that's a mesh. Okay. All right. I think that's all I was missing.
And I'll also leave that in the description. It's a great resource for this particular concept, as using a 2D weather texture allows for more precise artistic control over where your Raymarched clouds are and how they look. I also had to, for the first time, use white noise to offset the rays and stop this banding effect commonly seen with raymarching. I actually did notice this in GameMaker as well, but thanks to the flat color pixel art style, it wasn't that noticeable. I also experimented with trying to stylize said clouds, but I wasn't too happy with the white noise effect on the clouds. It made them look more spray painted than real. Now, I still felt like things could be improved, but since I felt kind of burnt out on the clouds, I decided to put that aside and just get started with the project. At first, I started experimenting with the looks, starting with the shaders for the grass, trying out different stylized looks just to see what works and what doesn't. I also tried to model some rocks and see what looked decent with some shaders. Then I got started with the trees. I initially tried to use Blender's Tree Gen plugin, but it created a tree with 600,000 vertices. That's basically going to take half of my frame time budget to render, and especially if I was going to make a pretty shader for it, I had to scrap that and attempt to make my own. A day later, I did model my own tree, and it didn't go so well. Something about them just looked off before I even set up the shaders, but considering that it took me a full day to make, it left me feeling defeated from wanting to make the tree model again. So I spent the night researching some trees and stylizing.
I totally hear that. I have done a couple 3D projects, and that's like one of the worst things, is like you get to the end of it and you're like, you know what? I actually kind of wanted it to be in a different style. And so you're like, I guess I gotta redo it. And it's like, oh man, they take so long. Although I guess that's the same with pretty much any art style, is you'll like get to the end of animating a whole character and then you're like, oh, I kind of wanted them to have like a blue shirt instead. Or like, oh, I wanted it to be a sleeveless shirt, right? And so now you got to go through and and change everything. That can be pretty draining. I hate that.
Games like Genshin and Zelda, and got some rest. The next
Also, shout out to the Celeste music. I'm loving it. Is that what?
day I decided I didn't want to model my own trees, but luckily there was a tool I discovered during my research prior, Tree It. Within 30 minutes, I had a tree that was just a mere 3,000 vertices, even lower than my handmade tree, and I got started making a custom shader for it. After a few iterations, I got something I was happy with, and after a few more tweaks, I made this. This tree was perfect, pretty much exactly what I wanted, but I couldn't place down tens of thousands of this tree, so I ended up making the perfect imposter tree with lighting built in. From a distance, you can't even tell the difference between the imposter tree and the full detail tree, despite the imposter tree only being two intersecting quads. At this point, I was ready, was confident, and I believed I could start with the planet. So really quickly before we start the next chapter, I wanted to let you know that this video took forever to make, and that's obviously not even considering the thousands of hours I put to get to this point. There was actually a lot that I didn't get to cover in this video for length's sake.
Whoa.
I ended up putting all that into a separate video where I also go through my trial and error process. It's a little bit of a peek into my mind and my workflow. If you're interested in that, you can watch that on Coffee for the price of a coffee. Your support would be highly appreciated. Anyway, back to the video. So originally, my intention was not to make a Raymarched planet. A traditional mesh-based planet has huge benefits and neat tricks like scaling LOD that make it perfect for these types of games. That's why quad-tree or octree mesh-based planets are used almost exclusively everywhere. No Man's Sky uses a voxel-based octree planet. Kerbal Space Program uses a quad-tree-based planet. Space Engineers, which I believe also uses an octree voxel planet. So considering all that and the fact that I've already made a mini quad-tree planet, how hard could it be just to do that again, right? Wrong. You see, I never had to make a full-scale planet.
Famous
More
last
importantly,
words.
I never had to place anything on that planet's surface before, and I quickly learned that things wouldn't be as easy as I had hoped. So, considering I'm generating my planet's surface through noise, I can quickly calculate where the floor is just by reading from said noise. That's what I had hoped to use to place the trees in a performance way. But what I had failed to account for was that a planet made from vertices can only sample the height at its vertices. This results in a resolution mismatch.
Oh,
Now,
interesting.
there was 2 solutions to this issue. One, I can increase the resolution of the planet until floating wasn't visible. 2, I can raycast the trees onto the surface of the planet. The issue with the first solution is that memory consumption would become ridiculous with the current quad-tree system I was using. To put simply, I was generating the planet once and then caching all that mesh data even if the mesh wasn't in use. I did it this way because it's by far the most performant solution at the cost of memory. So, to scale up mesh resolution where it matters, while also keeping memory footprint acceptable, I would have to scrap the caching system and generate the planet's surface on the fly while discarding unused quad-tree chunks. This basically involves multi-threading and or computers. So instead of redoing the entire planet and ending up with a result that I'm not even sure I would be happy with, I decided I'd just use raymarching. Raymarching, as we've discussed and seen, by this point I already had a lot of experience with, and there's so many benefits to this. 1. There's no mesh you need to store, so the memory footprint is extremely low. 2. There's no pop-in. Since Raymarched resolution is per pixel, not per vertice, no matter how far or close you are to the planet, the detail is perfectly crisp. 3. It shows any changes you make to it in real time. This means that you can iterate very quickly on what planets look good and don't. So, before we start with the planet raymarching, let's revisit the technicalities. Remember I mentioned ray tracing? Ray tracing is often used to accelerate raymarching. You might have heard algorithms such as a ray box intersection or a ray sphere intersection, and they're used to encapsulate whatever is being raymarched. These functions output the distance to the object and the distance through the object in this case being the bounding box. And using these, we can know exactly where to raymarch and if we need to raymarch at all. For a box, this is what that looks like, and hopefully this is self-explanatory. Any pixel that is completely blacked out means that there's no raymarching to be done there. And obviously, the rest of the pixels you see show the distance through the box. So why is this important? Well, because we use the ray sphere intersection algorithm.
Man, this is making me want to do a raymarching project. This is so cool. This is insanely cool stuff. I had always thought like No Man's Sky, like how do they do that, you know? I mean, I never looked into it, but yeah, this is really cool.
To speed up raymarching for the planet, because fixed step raymarching is very inefficient without it. And while I told you that you shouldn't be using this for collisions, as you can see, in this case, the collisions are actually pretty accurate, and we're not actually going through that many ray steps. And this is essentially how the planet is being raymarched. I quickly plugged in the same planet texture that I created for the planet mesh generation into a very simple Raymarched shader. And within a few
I
hours,
should do that,
I
yeah.
had this. And yeah, I underestimated how
Oh
much
no.
step precision I would need for Raymarched terrain. And considering that I couldn't cheat with white noise offsetting like when I Raymarched the clouds, I would need to find a solution later. But for now, I just cranked the ray step count up and
If I have
ray
time
step
for it.
size down and
I'll
fixed
find
the
time.
issue. A few more days of experimenting and I also managed to optimize the raymarching. But it's also 10 times faster from far away, meaning I could have many planets on the screen at once and still be completely fine. So with that done,
That's
now,
so cool.
I started porting all my shader code from Godot to a pure GLSL compute shader, so that
All right, so here's the thing that I no longer understand is how, like, I don't understand how this is not a mesh, because basically, like, because they're saying that it doesn't have memory, like it doesn't fill up your memory. Is that just because it's not loading the whole mesh at once? Is that what's going on? I mean, it's got to load the mesh to some degree, right? I'm a little lost on that, because I was thinking that it was kind of like, you know, you have some sort of procedural volumetric object and you can just render that. But I guess I don't really understand how this is not a mesh. I guess it's just saying that, like, basically, is Raymarching just like a really good LOD tool for the mesh?
I can make my own custom rendering pipeline.
I must have missed
using
something.
Godot's built-in fancy new compositor effect system. After porting, I finally worked on the atmosphere and some basic lighting to make the planet feel a little less bold. This was such a pain. It's so easy to mess up the maps and
Such a
end up with
pain.
a weirdly thin feeling atmosphere with improper scattering, and that's if you even get it to work in the first place. So after a week straight of nearly pulling my hair out, I managed to finally pull it off, and personally, I'm very happy with the result. So glad I didn't give up on the atmosphere or compromise by going with the first result. I quickly also spent some time revamping and improving the planet procedural texturing and fixed the ocean depth bug that had been bothering me for some time. And that's it, a full-scale Raymarched planet which has now taken the crown for the most complex shader I've ever wrote to date. Well, it's only gotten more complex since my additions to the shader to get the galaxy working. But that will be for the next video. And that's part 1 of this project. Might have noticed that I never got to place down the grass or the trees. That will be for the next part, along with hopefully clouds and the finished galaxy. So be sure to subscribe so you don't miss that, and please do like the video if you enjoyed. Since this channel is new, any and all algorithm engagement would help a lot. If you made it this far, leave a comment letting me know what you'd like from my coffee page. See you next time.
Wow. Very, very cool. Yeah, this definitely has me wanting to look into raymarching. Volumetric raymarching. Yeah, I guess it's it has to do with the memory to display the mesh. So the memory to load the mesh is nothing. The real issue is that you have to fill the bitmap buffer, right? Like you have to fill your graphics buffer with data. That's probably the real issue, isn't it? And so this eliminates that need because it's just really good level of detail. That's so interesting. All right, yeah, I'm going to put that on my list of potential things to do at some point, like try to make a planet with raymarching. That'd be so cool. Like it doesn't have to be a game, just like I just want to try it out. Just have a little camera that can fly at a planet, and then we can put a bunch of stuff that pops into, well, it doesn't even pop into view. It just shows up into view. That'd be cool. Awesome. Well, thanks for the suggestion. This was an excellent first React video. So anyway, there it is. Definitely check out Aria. This was their first YouTube video, and it was excellent. And check out their game too. If you want me to react to something on stream, join my Discord and request it. I'll get better at this reacting thing, I'm sure. I'm pretty lousy right now, but we gotta learn somehow, right? Anyway, that's it for me. Check out Droppy Ball. See ya!